let us go to the relation between the angles and the sides. So before that, here I have written one symbol, that is theta. This is a Greek letter. Usually we denote this theta to represent the angles. So I have written theta. Previously I was writing angle 1 r small a r x, like that I was writing. Now I started writing a Greek letter because x and y we will be using so many places, you will get confused. So better always use theta. Even if you don't use theta, you can use c. So whatever is convenient, comfortable, understandable, you can use it. But I will use theta here. So now you can keep theta here or here. You cannot keep theta here because that is already 90 degrees. Okay. So this theta is unknown. This theta can be anything. So theta is an acute angle. I told you in my first video, right? So now the first ratio is sine of angle theta. Sine of angle theta. So what is sine of angle theta? Right? That means sine of angle theta. Theta means sine of angle is one definition, that is with respect to the theta. I will write here, which is equal to opposite side to theta and divided by hypotenuse. Right. So now let us write this in short. Sine in short I will write sine, sin. Sin some people will use it, but I will use sine only. I will pronounce it like sine. So sine theta. You can write sine c also. Whatever symbol you are writing here, you can write some. Sine c, sine theta are same. So then what happened? Opposite side to theta. Then what will be the opposite side to theta? This is opposite side. Okay. So opposite side is nothing but AB and hypotenuse is nothing but AC. So sin theta is equal to AB by AC. This is the first relation between the sides and the angle. So because it is in the form of ratio, that is why we call it as a trigonometric ratio. So it is a trigonometric ratio, right? So this is the first trigonometric ratio. Let us go to second trigonometric ratio. So cosine of angle theta. So all the definitions are with respect to this angle only, right? So in simple, so what will be the definition here? Adjacent side to theta upon hypotenuse, right? So what is adjacent side here? Opposite side is the side opposite to theta. Adjacent side is the other one. Already one name is hypotenuse, one opposite side. You can have this as a adjacent side. So now let us write in short. Cosine we write as a cos. Cos theta, or you can write cos C also. You can write sin A also. You can write cos A also. Okay. So any one is okay, because I am using theta here. I am defining the ratios with respect to the theta. So cos theta is equal to, adjacent side is nothing but BC and hypotenuse is nothing but AC. So logically you can remember like how one is opposite side upon hypotenuse, the other one is adjacent side upon hypotenuse. So, the opposite side upon hypotenuse is nothing but sine of angle. The adjacent side upon hypotenuse is nothing but cosine of angle. Third one you can automatically guess. I will come with guessing. So, opposite side to theta by adjacent side to theta. Okay, I will rub this, you will get confused. I will rub this. Okay. So, this is called as tangent of angle theta. So, in short, what I am going to do, tangent can be written as tan and theta is tan theta. So, already opposite sides are there. Opposite side is nothing but AB and adjacent side is nothing but BC. So, now there are three trigonometric ratios. So, using these three ratios, we can have other three more ratios, right? Three more ratios. Very simple, reciprocal. So, the reciprocals I will write in front of them only. So, the reciprocal of cosine is cosecant of angle. The reciprocal to second one, cosine, is nothing but secant of angle. And the tangent reciprocal is cotangent of angle theta. So, let us write. I am not because diagram I have rubbed it, I got all the information. I will just display the information. In short, some people will say CSC theta, or some people will say COSEC. I will write cosec theta, again cosec, somewhat odd pronunciation. I will use the cosecant theta, which is equal to reciprocal of sine. So, I can write 1 upon sine theta, or I can write hypotenuse upon opposite side, or simply I can write AC upon AB. In three ways you can remember. One is cosecant theta, 1 upon sine theta already you know, just reciprocal it. So, if you want a definition cosecant, you take the reciprocal of sine, hypotenuse upon opposite side is the reciprocal. So, the definition of cosecant is hypotenuse, the ratio between hypotenuse to the opposite side to the angle. So, now same way secant. In short, I will be using SEC, sec, but I pronounce it like secant theta. So, secant theta is nothing but 1 upon cos theta, because it is reciprocal of cos theta. So, it is also we can represent, if you want the definition, so cosine is adjacent upon hypotenuse and the secant is hypotenuse upon adjacent side. So, this is nothing but AC upon BC, AC upon BC, all are same. Now, cotangent, I write simply COT, cot. You can use cot or you can use cotan theta. Cotan theta, cot theta is equal to 1 upon tan theta, which is equal to adjacent upon opposite side and which is equal to BC upon AB. So, in the same way you can write sin theta is nothing but 1 upon cosecant theta. Reciprocal, both are reciprocals to each other. So, cos theta we can write 1 upon secant theta. Secant theta is equal to 1 upon cos theta, or cos theta is equal to 1 upon secant theta. cos theta is equal to 1 upon tan theta, tan theta is equal to 1 upon cot theta. Okay. So, this is how there are 6 trigonometric ratios. 6 trigonometric ratios. 3 are main and 3 are reciprocal. I hope you have understood. All of you understand these ratios, definitions, and by heart it. See you in the next class. Hello. Every time in my videos I am just giving you some concepts, I am teaching you some concepts. And when I am teaching in the class, I found some students need some extra support in the questions. That means concept के ऊपर questions. So that is why I have appointed an assistant. So my assistant is going to explain the questions on which I have already explained my concept. So after every my concept, that means after teaching of my concept, immediately in the next row questions also will be added in that. So on every concept minimum 4 questions will be added with explanation and with neat doing and everything. I hope this will be useful to all the students. So आपको यूज़फुल है तो ये वीडियो आपका फ्रेंड्स को भी शेयर कर सकते हैं. थैंक यू. हैव अ नाइस लर्निंग.
I am Mehak Paryani and I am a principal sir's personal assistant. Currently I am pursuing my masters, and from today onwards I will take the examples of the concepts which are taught by the principal sir in the previous classes. As previously sir has explained trigonometric ratios and their formulas. So now we will be solving some examples based on those concepts. So now here it is a right angle triangle PQR, which is right angle at Q. So now we have to, this is the given part, and we have to find the values. We have to find tan P minus cot R. So thus it is a right angle triangle. So first of all, if we get any right angle triangle, we have to apply Pythagoras theorem. So applying Pythagoras theorem, we get as Pythagoras theorem says, PR square is equals to QR square plus PQ square. So as we have the value of PR and QR, PR and QP, we need to find the value of QR. So thus we will substitute the values in the equation. Thus we will get PR is 13, QR we don't know, we have to find the value, and PQ is 12. So we will find value of QR from this equation. Thus we will obtain the value of QR, which comes to be thus QR square comes to be 25. So we have to get the value of QR, which is square root of 25, which comes to be 5. So thus now we know all the sides of right angle triangle. So now we can find the value of tan P and cot R from that. So as we know that tan P, tan of any angle, we have the formula, which is first we have to consider an angle at P. So tan has a formula opposite upon adjacent. So side opposite to angle P is QR and adjacent is PQ. So thus we will write the formula QR upon PQ, which comes to be 5 upon 12. Now we have gotten the value of tan P. Now further we will find the value of cot R, which comes to be, cot R is adjacent upon hypotenuse. So now here we have to find an angle, considering an angle at angle R, we will get the side opposite to angle R is PQ and adjacent is QR. So thus we will write the formula PQ upon QR. Cot R has a formula adjacent upon hypotenuse. So we will write the value as QR upon PQ, which comes to be 5 upon 12. Now we have both the values of tan p and cota, and we will substitute the values of tan p and cota in the equation which is given in the question, as we have to find these values. So tan p minus cota we have to find, and we have the values, so we will substitute the values in the equation. We will get tan p has a value 5/12 and cota has a value 5/12. So the answer we got is 0. So thus we have obtained the result, and we will further continue the next questions in the upcoming classes. Hi, so this is the next question which we are going to solve. Here we are given the value of sin A is equivalent to 3/4, and we have to find the value of cos A into tan A. So here we will consider right angle triangle, which is right angle at B, and we have, as we have been given a value of sin A, so angle is at A. So now, as we know the value of sin A from the trigonometric ratios, the formula is opposite upon hypotenuse. So opposite side is BC, and to angle A, side opposite is BC and hypotenuse is AC. So now, which is given 3/4. So BC here we can put the value as of side BC is 3 and AC is 4. So here we know two sides, but in order to find any all the remaining values of the trigonometric ratios, we need to know all the three sides. So here, as this is a right angle triangle, so we will apply Pythagoras theorem. So by Pythagoras theorem we get AC square is equivalent to AB square plus BC square. So we will substitute the values which we have. Now we have the value of AC is 4 square and AB is not known to us, we have to find that, and BC is 3 square. So now we will get the value of AB square as 4 square minus 3 square. So which comes to be 16 minus 9, AB square is 7. So AB comes to be square root of 7. Now we have the value of AB, and we will put the value in the triangle. Now we have to find the value as the given question asks for the value of cos A and tan A, and all the three sides are known. So we will find the value of cos A first, and then we will find the value of tan A. So cos A comes to be adjacent side, which is adjacent to angle A upon hypotenuse, which comes to be AB upon AC, so which is root 7 upon 4, and tan A. So we have to, for solving all these questions, we need to remember all the trigonometric ratios formulas. So tan A has a value, so formula for tan A is side opposite to tan A, which is BC, and side which is adjacent to tan A, which is AB. So BC upon AB, which comes to be 3 upon root 7. Thus we have both the values of cos A and tan A. So while solving all these problems, first of all we need to notice which angles we need to note in order to find. So in find the answer, so here we need to know the angles which are cos A and tan A. So we have found out the values of cos A and tan A separately and put those values in the equation. So now putting the value of cos A and tan A, we get cos A it is equivalent to root 7 upon 4, and tan A, which is 3 upon root 7. So we have now we will put the values in the equation, which comes to be root 7 upon 4 into 3 upon root 7. So here we will get as the value is 3 upon 4. This is the required result. Thank you. Hi. So now we are going to solve this question. So the given parts are 15 cot A is equivalent to 8, and we have to find sin A and sec A. So here we will again consider a right angle triangle which is right angle at B, and we have to consider an angle at A. So so simplifying the equation, we get cot A is equivalent to 8 upon 15. So as we know from the relations of the trigonometric ratios, cot A is equivalent to adjacent upon hypotenuse. So the angle which is adjacent to angle A, which it is side which is adjacent to angle A is AB and opposite is BC. So we will put the value as AB upon BC. So here we have the value of AB which is 8 and BC is nothing but 15. But here we know just the two sides. So to find all the any of the relations of trigonometric ratios, we need to know all the three sides. So here we will apply Pythagoras theorem. Since it is a right angle triangle, we get by applying Pythagoras theorem AC square is equivalent to AB square plus BC square. So here we have the values of AB and BC side. We'll put the values in the equation. 8 square plus 15 square, thus we get 64 plus 225, which comes to be 289. So since 289 is the square root of 17, we get AC is equivalent to 17. Thus we know the third side, which is 17. Now we need to find the sin A and sec A. Thus we'll find sin A. So formula for sin A is side opposite to angle A, which is BC, and hypotenuse is AC. So we will put the value as BC upon AC, which comes to be 15 upon 17. So now we have the value of sin A. Next we have to find the value of sec A. Sec A, the formula for sec A is hypotenuse upon, which is hypotenuse AC, and upon adjacent, which is AB. AC upon AB comes to be 17 upon 8. Now we have both the values as 15 upon 17. We have both the values of sin A and sec A. Stop. Hi. Here we have the question as sin A, the value of sin A is given, and here there is a change. We need to find all the trigonometric ratios. So first of all, you should know what are the values required in the question that you need to find out. So value of sin A is already given. So here we will find the values of cos A, and the next trigonometric ratio is tan A, and next is cosec A, next one is sec A, last one is cot A. So now we will obtain these all values. So here we have been given sin A. So sin A, we will consider the required the given equation. Sin A is 1 upon 3, it has been given. So we will obtain the formula for sin A, which is angled at A. So sin A is nothing but opposite upon hypotenuse. So we will write it as BC upon AC. So thus the value of BC from the equation we get 1 and AC comes to be 3. So now we have two values. So for solving all the trigonometric relations, we need to know all the three sides. So third side we will get by applying Pythagoras theorem. As we know, Pythagoras theorem is nothing but AC square is equals to AB square plus BC square. So now here we know the value of AC, which is 3 square, and AB we don't know, we have to find out, and BC is 1 square. So now here we will obtain the value of AB square by solving the equation, which comes to be 9, which is nothing but 3 square minus 1 square, which we will get 9 minus 1, which is 8. So AB square comes to be 8. So taking the square root of AB, we will get 2 root 2. As 8 is cube root of 2, so you will be getting 2 root 2 as the value of AB. Now we have all the three sides, and AB comes to be 2 root 2. Now we have to find the remaining trigonometric relations. So cos A, first of all we will find the value of cos A. So cos A, so formula for cos A is side opposite to angle A, side adjacent to angle A, which is AB, and hypotenuse, which is AC. AB upon AC. So AB is, we have calculated the value of AB as 2 root 2 upon AC, which is nothing but 3. So thus we have found out the value of cos A, which comes to be 2 root 2 upon 3. Now next we will find out the value of tan A. Tan A, formula for tan A is side opposite to angle A, which is BC, and side which is adjacent to angle A, which is AB. So we will write BC upon AB, which is 1 upon 2 root 2 AB. So now we have the value of tan A also. Next we have to find out the value of cosec A. So there is a specific formula for this. As we know, cosec A is nothing but the reciprocal of sin A. So we will use the formula and obtain the result. Cosec A is 1 upon sin A. So here we just have to take the reciprocal of the value which we have. So cosec A is nothing but the reciprocal of 1 upon sin A. So reciprocal of sin A comes to be 3. We have taken the values from the previous obtained result. Now next we have to find the value of sec A. Sec A is these are all reciprocal relations. So sec A has a reciprocal relation with cos A. So sec A is nothing but 1 upon cos A. So the reciprocal of cos A we have to take the values which are obtained previously. So reciprocal will be nothing but 3 upon 2 root 2. Now next we have to find the last value, which is cot A. Cot A is nothing but the reciprocal of tan A. So cot A thus comes to be, cot A is equivalent to 1 upon tan A, which comes to be 1 upon reciprocal of tan A is nothing but 2 root 2. So thus now we have obtained the required result, and we have all the trigonometric ratios. Just one trigonometric ratio was given, and we obtained all the values of the trigonometric ratios by solving. Thank you. Hi. So here we have to solve this particular question. This is a very important question, so just focus. We have been given the value as 4 tan theta is equivalent to 3, and we need to solve this particular equation. So here first of all we will consider the equation which is given to us, which is tan theta is equivalent to 3 by 4, and this is the equation which we will use to solve this problem. So here the value of tan theta is given to us, which is 3 by 4. So tan theta is nothing but opposite upon adjacent. So opposite is BC upon adjacent is AB. So we will put the value here, which is BC is 3 and AB is 4. So here we got the value of BC and AB. This is a right angle triangle. So we need to know all the 3 sides of any right angle triangle to solve a particular question. So third side we will find by applying Pythagoras theorem. We get AC square is equivalent to AB square plus BC square. So here we will get AB square, which is 4 square, plus BC square, which is 3 square. So which is nothing but 25. So AC is nothing but 5. So here we have gotten all the values. So now we will consider the equation which is given in the question. So here both the numerator and denominator we will divide by cos theta. So if we divide both numerator and denominator, we will get tan theta in the place of 4 in the place of sin theta. So now we will write it as 4 tan theta minus cos theta upon cos theta is 1 plus 1 upon cos theta, and we will get 4 in the denominator, 4 tan theta plus 1 minus 1 upon cos theta. Now here we know the value of tan theta, but we don't know the value of cos theta. So we'll find the value of cos theta, which is cos theta is adjacent upon hypotenuse. Adjacent is AB upon AC, which is 4 upon 5. But we need to know the value of 1 upon cos theta, which is nothing but the reciprocal of cos theta. So now we have the value of cos theta, and reciprocal of cos theta is nothing but 5 upon 4. So 1 upon cos theta, we have got the value is 5 upon 4. Now we will put the values. We have all the values which are required to solve the equation. So 4 tan theta is 3 upon 4 minus 1 plus 1 upon cos theta is 5 upon 4. And denominator also will substitute the values. 4 tan theta is 3 upon 4 and 1 upon cos theta is 5 upon 4. Now we will solve it as 4 will get cancelled here also. Denominator also 4 will get cancelled. Further, we will get as 3 minus 1 plus 5 upon 4 and 3 plus 1 minus 5 upon 4, which is 2 plus 5 upon 4 and 4 minus 5 upon 4. So here we will get it as 8 plus 5 upon 4 and 16 minus 5 upon 4. So we will get the required result as 13 upon 4 into, which is 4 upon 11. So thus we will get the required result as 13 upon 11, and this is the required result which we will get. Thank you. Hi. So this is a new example which we are going to solve. Here we are given an equation which is 5 cos A minus 12 sin A is equivalent to 0, and we need to find the value of this equation. So here we will again consider a right angle triangle. We will solve the first simultaneously solve the equation which is already given, which is 5 cos A minus 12 sin A is equivalent to 0. First we will simplify the equation, which comes to be 5 cos A equivalent to 12 sin A. Thus we can get the values of cos A upon sin A. Here it comes to be 12 upon 5. So here we have the value of cos A upon sin A. So cos A upon sin A is nothing but cot A. So we have the value of cot A, which is 12 upon 5, and cot A is nothing but adjacent upon opposite side. So adjacent is AB and opposite is BC. So here we will put the value of AB is 12 and BC is 5. So here, since this is a right angle triangle and we don't know the third side, we will find the value of AC. So considering Pythagoras theorem, we get AC square is equivalent to AB square plus BC square. So here we will get the value of AC square as, which is nothing but AC square is equivalent to 169, which is 13. AC comes to be 13. Thus we know all the sides now. Now here for solving the we will solve the equation. So for solving the equation we need to know the value of sin A and cos A. So I will first of all calculate the value of sin A, as we now know all the sides of the triangle. So sin A is nothing but opposite upon hypotenuse, which is BC upon AC, which comes as 5 upon 13. So here we have the value of sin A. So now further we will calculate the value of cos A, which is cos A is nothing but adjacent upon hypotenuse, which is AB upon AC. So which is nothing but 12 upon 13. So here we have both the values of sin A and cos A. Now we will put the values of sin A and cos A in the equation. So we will get as 5 upon 13 plus 12 upon 13 and 2 into 12 upon 13 value of cos A minus the value of sin A. So we have to solve this we will get 17 as denominators are equal, so we will add the numerator, which comes to be 17 upon 13, and we will further solve the denominator, which is 24 upon 13 minus 5 upon 13, which is nothing but 17 upon 13, and this is 24 minus 5 is 19 upon 13. So solving we will get 17 upon 13 into 13 upon 19. We will get the answer as 17 upon 19. This is the required answer for the solution, for the question. Thanks.